Section 5.2, example 7, evaluating limits of sequences of partial sums. So for each of the sequences, use a sequence of partial sums to determine whether the series converges or diverges. So determining partial sums, we're just looking at a finite sum to help us come up with like a little rule or something that we could kind of look at. So let's see. I'm going to look at the first few sums. So we'll say like S1, 2, 3, 4. Hopefully we see a pattern after 4. But this will be 1 over 2. Here that's going to be 1 over 2 plus 2 over 3. 1 over 2, 2 over 3 plus 3 over 4. 1 over 2 plus 2 over 3 plus 3 over 4 plus 4 over 5. All right, so in order to prove that it converges, we have to find a value that's larger, but in order to prove it diverges, we have to prove a value smaller diverges as well. So as I see these numbers getting progressively bigger, it kind of looks like they're going to go off to infinity. So I'm going to pick a value that's slightly smaller so that we could prove that it diverges, sadly. All right, so for each of these, I know that 2 over 3, that's going to be greater than 1 over 2. So we could use that there. 3 over 4, I know that's greater than 1 over 2. So what I'm predicting, or what I'm like contemplating right now, is us, instead of using all of these fractions, we could use the value 1 over 2 for each of them. Like for instance, I know that here 1 over 2 is equal to 1 over 2, but here, these values here, that value there is going to be larger than 1 over 2 plus 1 over 2. And same thing here, this value here is going to be larger than 1 over 2 plus 1 over 2 plus 1 over 2. Here as well, this time we're looking at 4 copies. So for the first partial sum, we have like 1 times 1 over 2. For the second partial sum, we have 2 copies of the same thing that we're adding together. Here we have 3 copies being added together. Here we have 4 copies being added together. And all of these values here are smaller, actually significantly smaller as we keep going along. These are significantly smaller than the values that we came up with over here. And because of that, I know that these are going to be smaller. So if this diverges while it's smaller, we know that this is also going to diverge. So what I'm assuming is that we know that S sub k, some random value k, whatever that sum is, it's going to be somewhat larger than k times 1 over 2. So k copies of what we're calling 1 over 2, because all of these are going to be larger than 1 over 2. So let's look at this, take the limit of that to see what we get. So the limit as k approaches infinity of k times 1 over 2. This goes off to infinity. So if that goes off to infinity, that tells us that this here as well goes off to infinity, which means that the entire thing just goes off to infinity. So we would say that the sequence or the series diverges. So diverges to infinity. All right, let's take a look at this alternating series. All right, so we have S1, that's just going to be -1. S2 -1 + 1. Okay, S3, -1 + 1 - 1. Hopefully by 4 we see some sort of pattern. So here we get -1. Here we get 0. Here these two subtract out and we're left with -1. Here those subtract out, we get 0. So these are alternating. They're alternating between 0 and 1. And because we don't end up at a specific number, we end up either at 0 or we end up at 1. We can't state this as actually converging or diverging. So because of that, we say that the sums alternate and therefore the sequence diverges. There are going to be times where an alternating sequence converges, but we'll see that here in a few sections. And lastly, part C. Let's see what we end up with. Let's look at the first few partial sums. So S1, that's going to be 1/1 times 2, which is 2, just 1/2. S2 is going to be equal to 1/2 plus, when n is equal to 2, we have 2 times 3, which is 6. S3, hopefully we see a pattern by the fourth term. 1/2 plus 1/6 plus the third term, 3 times 4 is 12. And the last one, 1/2 plus 1/6 plus 1/12, 4. 4 times 5 is 20, so 1/20. And let's see if we see any sort of pattern. Here, this ends up just being 1/2. We're going to multiply that by 3. So 3, 4/6. Or this ends up being 2/3. And we need, we know that this is 2/3. So we can multiply both top and bottom by 4. 8, 9/12. Which simplifies to 3/4. We know this whole thing is 3/4, so we're going to multiply by 5. So 15 16/20, which simplifies to 4/5. So here, instead of looking at this sum here, I see this as a sequence of, let's see, how can we say it? So like S of k ends up being k/k plus 1. So k for the first term, k plus 1. K for the second term, k plus 1. All right, I like it. So k/k plus 1. And now this, we could take the limit of it to see what we end up getting. So the limit as k approaches infinity, k/k plus 1, that's a limit as k approaches infinity of 1/1 plus 1/k, which ends up going to 1. So we would say this this converges to 1. So converges to 1. And I believe that is it, right? Yep, that's it. If you have any questions, please feel free to ask. Otherwise, bye.